Welcome back, my dear future leaders. This is Hershey, your science educator, is back with the chapter number 7, which is Measurement and Motion of your course book, Science Horizon, Class 6, Acknowledged series by Amit Publishing House. So let's see what we are going to learn today in this chapter. The chapter contains are why do we measure things? How do we measure things? And how is length measured? Now we'll also learn about the motions, the types of motions, and the story of transport. So are you all excited to learn about these things? So quickly start with the chapter, kids. Now when you stand with your class in the assembly, how do you stand? You arrange or you stand in a queue, right? And the teachers arrange you in the sequence, how? According to your length, right? So the smaller child who is not smaller child stands in the front of the row and the position moves on and the taller ones at the back, right? So this is how we arrange the kids in the queue. When you buy a new school bag, how what all things you are seeing while purchasing a new school bag? You see that the how big the bag is and the size, you can say the size of the bag you are taking care while purchasing the new school bag, right? So it is estimating that the number of books you bring to your school every day. That is how we are going to choose the size of the bag. Now, your parents we all buy the vegetables from the market, right? So how do we do it? We purchase it according to this weight, right? We take it like 1 kilo potatoes, 2 kgs and 5 kgs. So we get the weight and according to the weight of the vegetables, we take it from the market. So the vendor weighs it. This is the weighing machine. We calculate the weight on the weighing machine and you can see here is a thermometer. How thermometer is being used by us? We use this instrument to measure the temperature of our bodies. So these are some examples of measurement, right? So let's see how we are going to measure the things that we are going to purchase from the market or we have in our surroundings. We are estimating things all the time. In the scientific language, what is estimation? Estimation is nothing. It is measurement. How we purchase, like the vegetables we are purchasing, the fruits we are purchasing from the market, the grains we are purchasing, or we are going to buy the books and the notebooks, right? So many things we purchase, and before purchasing it, we should know the quantity, how much we are going to buy it. Otherwise, we'll get confused in the market that how much we need to purchase it, right? So the estimation is nothing, it is the measurement. All properties of matter can be measured using different methods. We are not following the same method to measure everything, right? So we have different methods to measure the objects. To measure length, we use scale. How we measure the length? With the help of scale. To measure how hot a substance is, we use thermometer. We also measure when we are sick, we have fever. How do we measure it? We measure with the help of thermometer only and so on. So let us try and how to measure different properties of matter. Matter is the object. And how do we measure things? Let's see. Humans are most evolved species. Oh, evolved means developed, right? So, we are most evolved species on the planet Earth. We live in a society and each one of us has different role to play, that we know this. Every individual have different tasks to do. To do these tasks, we need to measure the things every time, right? Then only we'll come to know that what is the quantity is needed by us, or we how much we need to travel. We'll see different, so many things we'll see here. To connect two cities by road or by rail, the distance between them needs to be measured. If you are moving from Delhi to Mumbai, how much time will it take? How you will calculate it or measure it? You should know the distance between Delhi and Mumbai, right? And how we calculate? There must be some unit to calculate it, right? And this is unit we have. We calculate the distance in kilometers, but every time it is not there. So kilometers is the largest unit. We have some smaller units also. We'll also discuss in detail in this chapter only. To make these roads and rail tracks, various amount of raw materials that is needed. What is needed? Iron is needed, wood, cement, sand, and many more. But how we are putting, there must be some measurement of the combination, or how much amount of iron is needed to build a road, how much wood is needed, how much sand, cement, how many labor would be there. So we need to calculate all this, then only we can proceed for the roads and for the rail tracks building, right? Farmers measure the area of their fields, calculate the amount of seed and fertilizers they will need for their crops. If you are a farmer, like, and how you will calculate that how much seeds you needed to grow a crop, how much fertilizers you needed, how much pesticides you needed, how much manure you needed. You need to have estimate before growing the crops, right? So scientists measure the amount of raw material for chemical reactions aimed at making new substances such as medicines, alloys, paints, clothes, and plastics. If you are sick, we go to doctor prescribes us medicines, right? It has some substances or the mixture of chemicals in it, right, which we take in and it reacts, right? So if they are not measuring it, cannot be done like any quantity you take it and you are making medicine. Is it so? कितना भी ले लिया और दवाई बना दी and you are consuming it. Will it be beneficial to you? It might be harmful for you, right? Or it is not working as it should have been, right? So measurement plays very vital role in our surroundings. So scientists are using this, the measurement, they are calculating and to make medicines, alloys, right? In the factories, the alloys are being made. So again, the right proportion needs to be put in the paints, the color, how much color will be added in it, how much this chemical, how much that chemical needs to be added to form a paint, clothes and plastic. So measurement is needed everywhere. Transporters measure the distance between places to further measure the amount of fuel needed by the automobiles to cover the distance, right? We are going from one place to another place, any means of transport. So how we will calculate it, how the fares are being calculated, how the fuels are being calculated. Suppose we are going by car and we are going just 100 kilometers away from our place. So how much fuel needs to be put in the car as fuel, right? Petrol, diesel, how much? So we need to calculate it. Tailors take measurement before making dresses according to the size. You all must have gone to the tailor for getting your clothes stitched, right? So how he is making your dress? He is measuring you, right? He takes the shoulders, the stomach, the waist, size, your length. So many things are needed, and according to your size only, the tailor is stitching your clothes. So measure is needed here also. In kitchen also, in hotels, in restaurants, the chef are also using or measuring the amount of raw materials. Raw materials means the vegetables and the other ingredients the chef is putting while cooking, right? Needed before using them in preparing a dish. We cannot put so much of salt in it, so much of spices in it, right? Otherwise, we won't be able to eat it, right? So, we need a measurement, a performance of students in the class. How teacher is measuring you, who is the top performer, who are all are the top 5 students of the class, the top 10 students of the class. So, teacher is measuring your performance, right? Conducting tests, quizzes, exams to help the teacher understand how much you have learned in your class. So measurement is needed everywhere, right? So we are measuring things all the time. So let's see how we are measuring the things. What all tools do we have to measure the things? So now how do we measure the things? For example, given above, you can understand and differentiate things. Different things are measured in different ways. We have seen that chef is measuring, tailor is also measuring the size of the cloth, how, and he is taking the measurement with the help of measurement tape, right? We are going to market, we are purchasing it, the quantity and the ingredients that we are putting. So many things are being done with the help of the measurements. Different things are measured in different ways. These measurements depend on the purpose for which we may measure and on the properties of the quantity or the substance to be measured, right? We need to measure the quantity also. Sometimes we measure the quantity, and according to the different properties of the matter, we are using the different methods of measurement, right? Usually we measure length, we measure mass, we measure volume, we measure current, and we also measure temperature. So here are some common examples where measurement is being used. As we have already discussed about the temperature, we have discussed about the length, right? Mass is the weight. Volume, we are measuring the liquids in the volume of the liquid, and the current and the temperature. So when we measure a quantity, we compare it with the standard value. For example, length is standard value. Standard value means there are some standard unit which is being followed entirely in the world. So the weight or the measure will remain same. The units measured will remain same wherever you go. If you are going to purchase 1 kilo apples, so it is same everywhere wherever you will go, or any place you are purchasing 1 kg apples. So means the quantity is same 1 kg of apple. You are going to buy 4-meter clothes. So if you are getting the clothes unstitched stuff, so you are asking a shopkeeper to give you the 4-meter of clothes. So the unit is same and you will get the same amount of cloth 4 meter wherever you go. So these are called standard values or standard units. For example, the length is generally measured in meters. How do we, what is the standard unit of measuring the length? It is meters. Mass is measured in grams or kilograms. Mass means weight. How we calculate or measure the weight? It is in grams and kilograms. Volume of liquid is measured in liters, right? These standard values are called units. So, the unit of measuring the volume is liter. Unit of measuring the mass is gram and kilogram. And unit of measuring the length is meter. So, all measurable properties of matter have units, but these units vary from place to place, right? So, some standard units have been defined, but the statement which was written, it varies from place to place. It is actually related with the ancient time. In earlier time, mass was measured in tola and sev, right? In earlier times, the people used to measure the weight. They used to measure in tola and sev. Unit in India. In Indian used to measure the weight in tola and sev. But in UK, it was pounds, right? So, it is not same. Tola and sev is, if you are going to UK and you are asking, you give me 1 tola of this, 1 sev of this. So, they won't understand. They will understand in pound only, right? It was, I am telling you the story of earlier time, right? Now, we have standard units and like length, Indian used to measure in gauge and distance are measured in cos. So, cos was near about 1.8 kilometer. 1 cos is equal to 1.8 kilometers or yojan in India. So, Indian used to measure the distance in cos or gauge, but in yard and miles in UK. So, how the people in UK was measuring the length? It was in yard and miles. So, you can see there is a difference country to country. It varies. So, value of these units differ from each other, which leads a lot of confusion in the exchange of information. I am asking the course, how much course the distance is. So, the people who is staying in UK, he was not able to understand that I am talking about what, because they are measuring in yards and they are measuring in miles. So, the values are different. To overcome this problem, standard units for measuring were developed by the group of scientists from all over the world. Now we have some standard unit. In the short form, you will write down SI. So, standard units we have, and it is being following in entire world. So, the measurement would be same. If you are asking 1 kg, it is same in India, it is same in UK, it is same in US, everywhere it is same. So, were developed by the group of scientists from all over the world. This was done in the conference of weight and measures in France in 1860. So, the standard unit was implemented in 1960 and this was developed in the conference of weight and measure where it was held in France. The set of units adopted in the conference is called the SI system of units. So, we call it SI system and this denotes for units. So, system, this international D unites in France. It is written in the French. I am not Very good in French, but let's try to read this out. Systeme Internationale de Unites in France. The SI units are adopted by the people all over the world in the areas such as education, research and industries. These help countries to exchange information and trade with each other smoothly. Nowadays, import export is also there. So how, if just think about that, if this system of measuring the SI method is not there, so how we would have been trading from different countries, like how we are exporting, how we are importing the things. It was very difficult to trade between the countries, right? So this system, the system of units, actually help the world, and we all are at same platform in the term of measurement, right? The following table gives the basic 7 SI units of measurements. Let's move to the table. Sometimes these units are not suitable for measuring a given quantity. In such cases, what do? We can be made bigger or smaller by multiplying or dividing by factors of 10, right? So we have some calculation methods, but before it, we should know the units, and with the units we can multiply or we can divide and we can calculate the measure. Smaller masses are measured in gram. We already know that we weight or the mass we calculate, measure in the grams. So gram is the smaller unit and the kilogram is the bigger unit of it, right? So 1 kg is equal to 1000 grams, or we can call it 1 gram is equal to 10 minus 3 kg, right? So gram is the smallest unit and milligram is also there. Milligram, gram, and then kgs. And we have the bigger units also, right? But first understand these commonly using units. So it is gram, kilogram, milligram. So 1 kilogram is equal to 1000 grams. So we write it gram in gm and kilogram in kg, right? Similarly, large distances can be measured. We are measuring the distance now. How we calculated? We calculated in the form of meters and kilometers. So 1 kilometer is equal to 1000 meters. As we have 1 kg is equal to 1000 gram. Similarly, 1 kilometer is equal to 1000 meters. Very small distances are measured in centimeters. So 1 meter is equal to 100 centimeters. Have you understood how we are measuring the length, how we are measuring the weight? Similarly, we'll move to the measuring of volume too. Hence, SI unit can be changed to suit the needs of the measurement. We can calculate it according to our needs. So, in this lesson, we'll learn about how we measure the length. We'll be talking about the length here. So, let's move to this part, how the length is measured. So, length is the most common physical quantity that needs to be measured for various purposes. Length can be defined as the distance between the 2 points. So, here is a point. I am standing here and my class is here. So, how I am moving it? How much distance do I need to cover to reach to my class? So we will measure it with the meters, centimeters and the kilometers, right? One is to know the dimension or size of an object. For example, the length of a book. You have a book with you. You need to measure it, you want that you should know that what is the length of this book. So how you are going to measure it? So first you should have a object and to length of the book, length, width and height. We can measure it, we can height of a room and so on. First you need to have a object for which you are measuring the length, width or height, right? In the other is to measure the distance, like I showed you in this example. So distance between the 2 points, this was the point where I am standing and this is the another point where I have to reach. This is my classroom, so I am moving from this place to my classroom. So how will I calculate it, right? So for example, the approximate distance. So they have given the example, the approximate, the rough idea. It is not real. So it depends the how you are going, the what route you are taking to reach from Delhi to Mumbai. So they have just taken an example that approximately distance between Delhi and Mumbai, it is 1400 kilometers, right? So since ancient times, the length has been measured in different units. In ancient time, there was no standard unit because it was adopted by the world. In which year we have just learned? In 1960, it was decided the standard units which we are following now. But before 1960, people used to use what? Some non-standard units. We have learned the standard units. It is being followed in entire world. Now we have some non-standard units also. The people who were there before 1960, they used to measure the length. We are talking about length only here. So first is handspan. Now what is handspan, kids? It is the distance between the tip of the little finger and the thumb of your hand when it is stretched, like in this way. This is the tip of the little finger to the tip of the thumb. You can measure it like I am measuring it. So when we are stretching it, so from this to this is called the hand span. Cubit, how we are measuring, the another way is cubit. Cubit is the distance between the elbow and the tip of the middle finger. You can see in this picture too, this is the hand span as I showed you, from the little finger to the tip of the thumb, and this is the forearm length, means we are measuring the this is cubit. Cubit, how we are measuring it? From the elbow, right? Elbow to tip of this finger, the little finger. You can see in this picture, this is the point of elbow and this is the point of middle finger. So we are taking because it is the longest one. This middle finger is the longest one. So that is why we have taken the tip of middle finger. So distance is this. We call it cubit. Now another way the people used to measure the length or the walking distance by the footsteps, distance between 2 feet when a person takes a step. One foot is here and the person has taken a step. Now his another foot or the second foot is here, right? So this is the difference between a step is measured as footsteps. So these are some non-standard units. Ancient Romans used this unit of length. So Romans used this method of footsteps, right, before 1960. You can understand that these units have different values for different people. How it varies from people to people? My hand is big, so my hand span would be covering more part, right? If a kid is measuring it with the hand span, he or she has small hand, so the length would be differ. Similarly, a person who is you'll say that he's taking bigger steps, so and a kid who is again taking the footsteps, but it is not as lengthy as a adult is taking, right? So there is a difference between footstep, there is a difference between hand span, and there is a difference between cubit, right? So it varies different in different people. If the length of a table is 7 hand span, right? If the length of a table, there is a table and we are measuring with our hand span. If it is 7 hand span with your hand, it could be 5 hand span with your father's hands, right? A adult person is measuring with its hand pen. Adult person has bigger hand as compared to a kid, right? So if you are measuring, it is your 7 hand span. If your father is measuring it, maybe it is 7 hand span, right? So it depends on the size of the hand, but this can again varies. अगर आप अपने father से tall है, so maybe आपका hand span is bigger than his, right? So it varies people to people. What happened in 1719? The metric system was developed in France. The unit of length named meter. So it was metric system was developed where it is in France in 1790, which is derived from the Greek word metron, right? Meaning, it means the measure, right? Measure, it means, this word means measure. A meter was a portion for the distance between the North Pole and the equator along a particular meridian passing through France. We all know the equator is an imaginary line that divides our earth into two equals half. First is North Pole we have, and at the bottom we have South Pole. So from equator it is the North Pole. This area has the northern hemisphere, and from the equator to South Pole, this is the southern hemisphere. So equator along a particular meridian, you all must have learned about the meridian in your SST classes. So passing through the France. So the unit of volume was derived from the unit of length. First, they have defined the unit of length, then unit of volume was derived. Also, larger and smaller multiples of these units could be created by multiplying or dividing by the powers of 10. You must have learned the measurement chapter in your maths, right? So, no need to explain it more and more on this. You already have done sums on it. Thus, this system was a decimal system because conversions could be done by shifting the decimal point. So, conversion also there from meter to centimeter, centimeter to meter, from meter to kilometers, and from kilometers to centimeters or meters, right? So, you can change it. Gradually, the metric system was adopted by the countries because it was scientific and simple. It was so simple and being followed everywhere. In modern times, the system was evolved into SI system of unit which is not universally, which is now universally accepted, right? We all are following the same SI method. The SI unit for length is what we already discussed. It is meter. It is useful to measure short length. This is the smaller unit, right? Short lengths and short distances. To measure very short distance, we have one more smaller unit than meter. It is millimeter. So 1 meter is equal to 100 centimeters and 1 centimeter is equal to 10 millimeters. Right? For measuring large distances, we have the larger unit which is kilometer. So 1 kilometer is equal to 1000 meters. The devices used for measuring small lengths and measuring tape or meter rod. These are some tools how we calculate or how we measure the length. It is measuring tape. Measuring tape is being used by the tailors, right? And the meter rods again to measure the length of a cloth and to check the height of the things. You measure length with the help of 15 centimeter ruler. We also measure the ruler in our schools, right? So how do we measure? Are we measuring it with measuring tape? No. Are we using measuring rod? No. So how we are measuring the length? We are doing it with the help of 15 centimeter rulers or 30 centimeter rulers. It comes in two variations, the 15 centimeter and the 30 centimeter ruler. You have to follow the correct method of measure the length of a given object. Again, some certain guidelines have been given how you will measure the length. So let's see, is it correct? The first picture is this ruler, a person is measuring the width of this box. So this is incorrect way to measure because it should be in straight line, right? Here you can see the difference, like it is 4.5 and it is more than it, right? So this is the wrong method of measuring it. Now this is also the wrong method because the corner of the ruler is here, right? So it should not be like this. You should start with the first line, or you will say it is 0, right? So 0 mark. You should start measuring with the 0 mark always. So while measuring length, you need to remember some rules. First, start always from the 1 centimeter mark on the ruler. So you should start from here only. Keep the ruler straight so that it is equidistant from the edge in all points. You should always keep your ruler straight, right? Keep your eye in front of the ruler at the same level to get the correct reading. Here you can see this is the correct one and these two methods are wrong. Why these are wrong? A person is measuring from here, right? So it could be different. Maybe he is saying it is 9 centimeter, right? Maybe it is 8.5 centimeter, but in actual it is 8 centimeter, right? Similarly, it is happening, a person is measuring from this position, maybe it could be 7.5 or 7 centimeters, right? Or maybe it can be a 8 or 8.5 centimeters. But to avoid this confusion, we should always keep eye in front of the ruler at the same level to get the correct reading. So we should follow these rules while we are measuring with the ruler. Always keep it straight. Start with first centimeter, 1 or 0. From this point only, don't keep it or don't start reading it from this inch, right? This is the wrong way of measuring the things, measuring the length. And always keep the ruler in front of your eye, right? In front of the ruler. Now, it is motion. So, we have learned about the measurement. We have seen the different units of measurement, why we needed, why the standard unit, and when this standard unit was adopted by globally by the world, right? Now it's time for the motion, as chapter name is measurement and motion. Now look around you, you will find many things living and non-living that we all know. Are they changing their position? So, character of a living being is motion or moving from one place to another, right? Living things move from one place to another. This is the character of living things. But non-living things cannot move from one place to another on their own, right? We need to push them or pull them. So, when an object or life from changing its position, it's said to be motion. I told you in the last chapter, there was a difference between the motion and the locomotion. Motion is we are moving our hand, we are moving our leg, but we are at the same position. And locomotion, we are changing our place, right? So motion is called when we are moving. Living things are moving. But now, do we decide whether it has changed its position? The change in position of a moving thing is noted with the reference to another thing which is stationary. Stationary means stand still. The object which is standing still. This is called the stationary. एक ही जगह पर रहना. This is stationary. As we play the game na statue. So statue means you are still, whatever position you are in, right? So let us understand with the help of an example. Keep a chair in the center of a room and stand about 2 meters left to it. Let's see, it is the chair, right? So this is, I'm just drawing it. Let's see, it is a chair and it is in the center of the room and you stand just 2 meters left to it. Here you are, this is 2 meters left to it. Now we have changed the position and now it is 2 meters right to it, right? So we can say that we are moving the chair. It is not moving on its own. We are moving the chair. This is the initial position. Now move about 2 meters right to the chair. So this is the final position. Your position with respect to the chair and walls of the room has changed because your position is changed. You were on the left side earlier. Now you are on the right side of the chair. Hence you are moved, but the position of the chair has not changed. This chair is stationary or still at one place. So the chair has not changed, hence it is stationary. Motion is always measured with the reference or to a stationary point. You are moving, but how you know that you are moving as compared to the stationary object, right? So chair is here. So we are comparing chair with you, right? So you are moving from here to here. So chair is still, it is stationary and you are moving. So we can say that we measure or we see the motion in the reference of the stationary object. When traveling in a bus or a train, you are in the motion with respect to the trees on the roadside because the trees, the houses, the poles, so many things are there. They are stationary at one point, and we are traveling. You are traveling in a train or you are traveling in a bus, right? So you are moving, and the trees, the houses, the poles that you see outside from the window pane, it is still. It is the stationary thing. You are motion with the respect of trees on the roadside, but you are not in motion with respect to the person sitting next to you, right? More passengers must be there in a train, right? They are sitting with you. But if you compare it with yourself with the other passengers, are you moving or are you stationary? All are stationary because we all are not moving. This is train which is moving from one place to another, right? So we should always compare it with the other objects as comparatively to other objects, right? So you are moving by car. So this is the example. The position of a car is here, right? And the house, the trees, objects are there. They are still. You see the stationary objects. They are fixed to one place. And who is moving? You are moving in a car, and you have traveled from this place to this place. After 5 seconds, you'll reach here, this point. So we define motion as the action of what? Changing location or position. If you're standing at one position, you are thinking that you are moving. No, you are not moving. You are at one place only. So motion of an object can be defined as the change in the position of an object with the time with reference to stationary point. So have you understood this language, this definition? What is motion now? It is the changing the position of an object with time, and with the reference of stationary objects. These are the stationary object. Car is moving and within 5 seconds it reached here, but stationary objects are still here. So with the reference of stationary objects. So motion is the change in position of an object. It is measured in terms of distance covered by an object in the given time. So how much time this car took to reach this place? It is 5 seconds. Within 5 seconds, the car reached from this point to this point. So time is also involved there. Motion means the car changed its position, but stationary objects are still at one place, right? So are we all clear, kids, about the motion? Right? Very good. So let's move on. We see the various living and non-living things moving around us. Do all of them move in the same way, right? In the last chapter, we have learned the movement in human skeleton or human body and the other animals, right? So, of course not. So, different objects move in different ways, some straight, some in curve or circle, some and to and fro, like some movements are there, to and fro. We have seen in our body also hinge joints, it is to and fro, to and fro. We have also seen the wavy like movement, curve movement, the curve fishes are making curve, right? So curve movement is there. So it is not that everyone is moving in a straight line. Some and to, fro and so. So let us identify the different type of motion. Now we will learn the different kinds of motion. First is rectilinear motion. So motion of a body in a straight line, right? We are moving in a straight line like soldiers. While they are in parade, they are moving in straight line. Like, have you seen it? They are moving in the straight line, right? So the motion of a car and the motion of dust particles in the air are the examples of rectilinear motion, right? You can see in this cycle rider is riding the bicycle in the straight path. So this is called the things that are moving in the straight line is called rectilinear motion. Now next type is curvilinear motion. This is the motion of a body on a curved path is called curvilinear motion. You can see here in a race, the riders, they have taken the curve. So this is called the curvilinear motion. The motion of a train when it is changing its direction, when it is changing. We are also like the car is moving in the straight way. This is rectilinear motion. When we are taking or we are changing the direction, so it is called the curvilinear motion. Right? Motion of stone thrown in the water. You just throw a stone in the water. It is going in a straight way? No, it is coming down. So it is taking because of the gravitational force. So it is coming towards like this. So it is again curvilinear motion. Examples of curvilinear motions, both recliner and curvilinear motions are together called what it is called? Translational motion, right? So together it is called translation motion. Else we have learned about the rectilinear motions and curvilinear motion, right? Now, circular motion or rotational motion. When a body moves along a definite path in such a way that its distance from a central point is always remain same. This is the central point of the needle and needles are moving here. So distance from this place to this place remains same always. So this is called the circular motion. Like I am drawing it, the distance is again, let's say it is 2 centimeters. For example, it is 2 centimeter. So a needle is moving from this point to this point. It is again the same distance 2 centimeter. From here to this point it is 2 centimeter. Again 2 centimeter. From this to this it is 2 centimeter. So from a point to the other point the distance remains same and it is moving in the circular motion. So when a body moves along with the definite path, so path is there, this circle, so this is the definite path and such a way the distance from the center point it always remains same. So this is called circular motion. It is moving in this circle and center part and the distance from center is always same. So we call it circular motion or circular motion. Examples, let's see the examples. Circular motion, the body moves in a circular path and different parts of the body move in path of different radius. So what do you call it? This is the radius, right? So path can be different but radius is same, means the distance between 2 point is same. This is called the circular move. For example, when you rotate a keychain on your finger like this, right? So it is moving here to there means it is moving in the circular motion, and distance from this tip or this finger to the key is remain same. This is again the example of circular motion, right? But the different parts of the keychain move different distances based on their distance from the finger, right? It is moving, it is same, but the distance it is taking, some is taking, it is also depend on the arrangements of the key, right? So it is distance from the finger. So have you understood the circular motion where the center point, the radius is same, the thing is moving in the circular motion, right? The distance from the center point to the second point is same. It is called the circular movement. Next is periodic motion. Periodic motion, again the things are moving in the circular motion only, but with the equal interval of time. Like fan, when a body moves in a such way that motion repeats after the same interval of time. It is moving but with the same interval. Parallel on the pendulum you must have seen, it is also moving from here to there, but in the same interval. The time is taking moving from one point to another is same every time. So this is the regular interval of time. So this is called the periodic motion. Periodic name is also suggesting period, means the time taken for one movement. So it is said to be periodic motion, motion of a fan, the hands of a clock, and the motion of the earth around the sun are examples of periodic motion. So how much time earth takes to revolve around the sun? It is 365 days and 6 hours, right? So it remains same, 365 days and 6 hours. So this is the periodic motion. Earth is moving in its fixed path, which is called orbit, in the circular motion, but every time when it completes its one revolution, it takes 365 days and 6 hours. So time is same, period is same. And what else we have seen? The hand of a clock. You must have seen the hands of a clock, right? Again, moving to the previous slide. How much time will it take if a second hand, 1 minute is equal to 60 seconds? It will remain same, like 1 minute is equal to 60 seconds only. So the period or the interval is same every time. The second hands, right? The second hand will take 60 seconds only to complete 1 minute, and the minute hand will take how many minutes? 60 minutes to complete it, right? And the hours will again take the same amount of time. So interval is same. This is called the periodic motion. So motion of a fan. The fan is moving in this direction. It is taking the same amount of time or with the same interval. So we have seen what's the second hand of a clock. It's exactly at the same position after every minute, after every second also, and hour also, right? Takes 1 hour. The hour hand will take 1 hour to move from one place to another. Let's say it is 12 o'clock now. Now, how much time will it take to complete 1 hour? When the hour hand will move to the position 1 hour only, na? And again from 1 to 2, this will take 1 hour. So period is same. So this is called the periodic motion. Now non-periodic motion. Non-periodic motion means the time is different. When the motion of a body does not repeat after the same interval of time, it is said to be non-periodic motion. Motion of a moving bus, leaves of plants, moving people are examples of non-periodic motion. Like every day you move from your home to your school, you go to your school and your school bus comes, right? And sometimes it takes 30 minutes to reach to your school, and sometimes it takes 35 minutes, sometimes it takes 40 minutes, or it can be 45 minutes too. So there's a difference between the time from your place to reaching to your school. So interval is different. So this is called the non-periodic motion, where the time is not fixed, right? So motion of a moving bus, leaves of a plant when it is growing, and moving people. Again, we are moving from one place to another. Sometimes it takes 10 minutes only, sometimes it takes 30 minutes. So it is not fixed. So this is called the non-periodic motion. The motion of a body may be classified into more than one type. For example, when you walk into your school, it is rectilinear, and the non-periodic motion, rectilinear motion, and it is a combination of two. You are moving in the straight path, right? You are not taking turns, or you are moving on the same straight path, so it is called the rectilinear motion. And it is not periodic motion. As I told you, sometimes you take to reach 25 minutes to your school, sometimes you take to reach 30 or 40 minutes to reach to your school. On the moon, around the motion of the moon, again moon rotates or revolves around the earth, right? It revolves around the earth. So it is again the rotational and periodic motion. It takes the same time. As I told you, the earth takes 365 days and how 6 hours to complete its one revolution. It is the rotational and the periodic motion. Periodic means interval is same every time, and it is moving in this portion, the circular motion. So this is called the rotational and periodic motion. Now it's time for the story of transport. Motion is one of the characteristics of living beings, right? Plants cannot move it fixed at one place and one position. Their paths move in different directions, right? It shows some movement. The leaves are growing, flowers are blooming, right? So animals move from one place to another place, various reasons to find out the food. They are looking for their mates and escaping themselves from predators, right? So motion is very important for humans as well. Human beings move long distances in their lifetime. We are moving from one place to another for doing many activities. You are going to school for studies. Your father must be going to office. Sorry, offices for their work, right? Your moms must be going for shopping to the market. So we move or we travel long distances in our life. The need for moving help them evolve in efficient transport system. We use transport system to move from one place to another. The car, the train, airplane, spacecraft, so means of transport depends on the time, the distance, and the money involved in it, right? We have already understood in the previous chapter about this. So in the beginning, human used to walk from one place to another. We used to walk by foot. Then they started using animals for going long distances, and to carry loads. The early men used to walk from one place to another and they carry loads on their shoulders to take it from one place to another, and later on we started using the animals to carry us and to carry our loads as well from one place to another. They also learned move across water bodies on wooden logs. How they used to cross the river or lake, they used to use the wooden logs, the simple wooden logs. Gradually they crafted, and rafts and boats were crafted later on as the knowledge came, as the time passed. The invention of the wheel brought the revolution in the transportation that we already discussed in the transportation chapter. They designed carts and carriages, and then came cars and buses. After that, the invention of cars and buses were there. The next invention was the steam engine. Later on, what happened? The steam engines were designed, right? Steam takes uh, power from the steam and it gives move to the trains. So the steam engines were designed and brought in trains, and then Wright brothers, they were invented the airplane, right? And human started traveling by air. So that is the story of transportation. And now humans have traveled to space with the spaceships, and moon through spacecrafts, right? So, however, most of the modern methods of transport consume large amount of fuel. Of course, they need fuel to run, right? It is available to us, and these are non-renewable resources. The fuel that we are using in the transports is non-renewable resource, right? And we need to conserve them. We should use these fuels wisely and try to conserve it. We also need to research and look for the alternative sources of energy which are renewable and as well as economical also. Fuels are also responsible for the pollution. All the fuels are non-renewable resources, right? So we should try to conserve it, because after that, if the fuel would be finished, can you think how we will move, how we will run the different means of transport, right? So we should look some other alternatives instead of using these fuels. Now, a fact to know is some terms and definitions have been given. Inches, and what is an inch? An inch was the width of a man's thumb in the 14th century. The earlier people used to use this. This is the non-standard unit. King Edward II of England ruled that 1 inch is equal to 3 grains of barley. Barley is jaw. So if you put 3 grains in the length, right? So end to end, lengthwise. So he declared, who? King Edward II of England. He ruled, and what he said, that 1 inch is equal to what? 3 grains of barley that are placed lengthwise, end to end. What is hand? A hand was approximately 5 inches or 5 digits across. Today, a hand is 4 inches and is used to measure horses from the ground to the horse wither or the shoulder. Now it is 4 inches. So span, foot, yard, cubit, length, pace we have discussed while the explanation of the chapter, right? space was left. Pace, the ancient Roman soldiers marched in paces which were the length of the double step. About 5 feet, 1,000 paces were a mile, right? So they calculated a mile is equal to 1,000 paces. Today a pace is the length of one step, 2 or 3 feet, approximately 2 to 3 feet measures of one pace, right? So these are some non-standard units. So let's recall what we have learned in this chapter. Measurement is very important for all kind of work that we do, right? To measure the quantity, it is compared with the standard values, which is called units nowadays. A unit of length, it is meter, and the mass is kg, means kilograms. A unit of time is second, and the unit of temperature is K, which is known as the degrees, the temperature, right? The SI units are used all over the world to maintain. Why we use this standard? Why we have defined them standard? To maintain the uniformity, right? To measure short distances, the unit centimeter, meter, and then for the large distances, it is kilometers. Now, while measuring the length of an object, the scale should be kept. We should remember these things. It should be kept straight. It should be you read it from the correct eye level, right? Otherwise, there may be variation in measurement. So, an object is said to be motion when its position changes with respect to a stationary point, right? Point which is still with respect of that stationary point, you will see the object is moving or not. Rectilinear motion is the motion of an object in the straight line like this way. Acha, curvilinear motion is the movement of body along with the curved path. It is object is moving on the curved path, which is called the curvilinear motion. When a motion repeats after the same interval of time, it is called periodic motion. And when the motion does not repeat after the same time of interval, it is called the non-periodical motion. So a motion contains two parts, either periodic or non-periodic, and the second is the rectilinear motion or curvilinear motion, right? So let's move to the question answers. First question, give 3 reasons why the measurement is important in our life. We have already discussed so many reasons why we are using measurement. So you can write down any 3 out of it, like the chef is using to measure the ingredients of raw material, measure the ingredients. We are going to purchase vegetables and fruits from the market, so we are measuring it. We are also following where the scientists are following when they are making the medicines or the paints or the plastic or the paper, right? And so many reasons we have discussed. You can write down any 3 out of it. How did people in the ancient times measure length? Give 2 examples. They used the cubit, the handspan, right? Cubit. So, foot space. These, why are the SI units preferred over local units to maintain the uniformity? What are the precautions to be observed while using a scale to measure lengths? The precaution that always keep the ruler straight, always start with the first 1 centimeter from the ruler, right? And always keep the ruler at your eye level, right? So what are, while moving in a train, the objects outside appear to be moving, but the person sitting near you does not. Why it happens so? You are sitting in a train is moving, But why you and the other passengers are not moving as referred to the what stationary, because all the passengers are stationary, right? The train is moving, right? So that is why you the person sitting near you, they are not moving, they are stationary. All right, kids. So we have completed this chapter, motion and movement. Hope you are now you know that what is motion, different types of motions, the movements, right? If you have enjoyed the session, I will catch you in the next chapter of science. Till then, stay excited for the clamp of another videos. Bye, kids. Take care of yourselves.